Alright, here we have our persistence of vision machine, which we call Frank. And it's just a device that spins around and flashes lights such that it prints out an owl. At the bottom, base, we have a clamp to hold it in place so it doesn't jostle too much when it's spinning. A PIR sensor that detects motion nearby and turns on, if it was on, when somebody comes close, and turns off when it hasn't detected motion for a while. Because of this, we can call it a low power machine, or conserves power as much as possible. This is what actually drives the motor. We plan to have 4 AA's driving it, 6 volts, but that ended up not actually providing enough power, so it only runs very well when running off another power supply. This just works by, when it detects motion from the PIR, it turns on this MOSFET, which lets current flow up to the motor, which is held in place by these 3 boards here. On top of the motor, we have the spinning arm, which has 2 circuit boards on it, but only one of them is actually connected. The other is just there as a counterbalance. It can tell where it is in the rotation using this Hall effect sensor. It's that little black thing right there. That, when it runs over this magnet, resets the MSP430. You can see it turns off there. On the board itself, we have 64 LEDs connected to 8 MOSFETs, and each MOSFET controls a group of 8 LEDs, which gives us a total of 16 pins that we need to control all of the lights, which is just enough for the MSP430 to handle. As we spin around, and even right now, every single time it prints out a single line, it turns on the first MOSFET, turns on all the LEDs that need to be turned on here, turns them off, and then moves to the next MOSFET. So even when you see it flashing there are 8 individual flashes for every single line that you see flash.